Hello students, today we're going to be talking about column chromatography. Another word for column chromatography is solid phase extraction, sometimes using the acronym SPE. We'll be using for our column this little thimble. It has a material that's in here that's silica gel, kind of like a sand, a white sand, and it's been coated with a hydrocarbon of 18 carbons long, C18, and it gives it a hydrophobic coating, which is nonpolar. Today in our experiment, we're going to work on separating a mixture of three colors, yellow, red, and blue, and they can be separated using the properties of the nonpolar material here and the eluent or the solvents we'll be putting in here, or the mobile phase. And depending on the polarity that we put in, we can separate these molecules, the three different colors in here, because they have different polarities. So to get started, you need to condition your solid phase extraction or your column with this material, and you can do that with some deionized water or tap water. So we can squirt a little bit of that in here. So I have DI here, and then I have some tap. We're finding actually that the polarity of water changes whether you're using tap water, which has ions in it, making it actually a little bit more polar, or using deionized water, which the ions have been removed. They actually have different polarity. So we're going to use a little tap water to get this going. Now, the lab talks about using a thimble or a plunger or something to push that through. In graduate school, I was exposed to a different technology of using a little bit of air pressure. So if you take your medicine dropper, take the top off, we're going to hook it to your hose, and we're going to make, and if you can find a number 4 stopper, or a number 3, or number 5, it'll all work. We are going to hook this up to air pressure. And you'll see it says air on it, and we're just going to give a little bit of air pressure to get this going. If you can hear it, that's too loud, so we just need a very little bit of air pressure. When we do that, we can put this on top, and pressing quite firmly, we can push water through, and hopefully you can see the drops coming out. So we'll just use air pressure to move the mobile phase, the eluent, through the column. This to get prepared. This happens a lot. They just pop off because of the pressure that's generated by pushing it on. So you'll have to find a happy medium pressure that will get us going, maybe not pop it off too much. And sometimes it'll pop. You want to make sure not get anything over with that too. Now you'll be able to find the ring stand and some holders for your thing, for your column in the lab, in your common areas. So I'm trying to push some more of the liquid through to get it conditioned today. And that's, maybe I need just a little bit more air pressure. So I do have to press quite firmly for it to push through. And we can see the water now coming out rapidly, and I'm not finding that happy medium of getting pressure through the system to the air. So we'll continue to work with that. Get that on nice and tight, and get this on nice and tight. Okay. Now once you push the column of water through there, it's dry, but it's wet there, because I didn't push it all the way through. We can go ahead and load our sample. Just like in thin layer chromatography, we want to make the smallest, what I call like a little plug, as we can. So using a couple of milliliters here, I know you'd love to know how many drops, but maybe 20. We don't want too big of a plug here. We want to then, once we've taken our color mixture, we want to put that onto the column. We don't want to fill up the column all the way to the top. We just want enough to get it on there. And once all the liquid has been absorbed on here, I'm going to stop. Now, you can almost see here that the yellow color is coming through in red. It's already getting some separation. I'm going to go ahead and use tap water to fill up the top. And I know I pushed the color on there because I'm not getting any color leaking back into my mobile phase. The tap water. So now I can go ahead and push. Oop, I can see the yellow color. Oop, and we got to be careful. Sometimes we can get wet pushing that on. The yellow is about ready to come off. So I'm going to now switch over to a cuvette, which we're going to use to do absorption spectroscopy, to collect the yellow color. So here we go. The yellow is coming off. The main thing here is we want to collect the color. Now if you don't quite fill out the cuvette, don't worry, we can add more water to it to get it to the proper level. The main thing is purity, to get just the yellow off. And I've got some good drops there already. And that is enough to do our spectroscopy so we can see the wavelength. But I got a little more yellow, so I'm going to try to push it off. Get myself a little wet. So that's okay. And if looks like I've got good yellow separation from the red and the other color blue in there. So I'm going to go ahead and add a little more water. And now that is ready for spectroscopy. Now we can continue to use water in here. And we can continue to separate the rest of the yellow color. I don't need it anymore. So I'm going to go ahead and just put it in my waste container. And it keeps coming off. We'll have to keep working with that to get it on there tighter and tighter. Okay, so we want to keep pushing the water through until all the yellow's off. But since I got a good clean, what they call fraction of the yellow, I don't need to collect anymore. Yellow is still coming off, but I see the red moving just a little bit. Once you've got to this stage and you think you've got most of the yellow, you can actually go to deionized water. It's nonpolar, and it will actually start to move the red a little bit. And it should get the rest of the yellow to come off. I can see the yellow starting to come off. And you just keep adding water until you get all the yellow. This is how you get color separation using column chromatography. So now that I've got the yellow essentially off, the red might be able to come off with the deionized water. But if we make the mobile phase more nonpolar, it will overcome the nonpolar interactions between the C18 cartridge and the nonpolar dye molecule. And so you can make a little solution of 5% isopropyl alcohol, and let's go ahead and use our DI water, and 95% water. It's better if you go 95% or 9.5 milliliters of our DI water here. That would work better, would be in great shape. And then I'm going to add a little bit of isopropyl alcohol. Now, it hasn't mixed very well, so maybe we could use a little stopper in here. Got one here. And I can use the kind of stopper and mix it up. Now, once I've got this mixture that has some nonpolar solvent in it, I can add that to the top. And I should be able to extract out the red. Okay, here comes the rest of the yellow. Ooh, that might have been too much because I'm seeing the blue starting to come off. And so I think I've had too much. There's a little bit of red. So I can collect the red, and it looks like I might get the red and the blue to come off, but there's the red coming off, and my blue is starting to come, so I can go ahead and go right to my next one. So I got good clean separation. I think I was a little lucky there. So now I can get the blue to come off. Okay, so now I got my blue, I've got my red, and I've got my yellow. And you can say, oh, that's not enough for the light to go through the cuvette to actually do the reading on those. So I can go ahead and just fill them up with water to complete the rest. The spectrometer will work great and pick up the colors that we're going to need and do the absorption spectroscopy. So you can start to see what the spectrum will look like for these colors. And help train your brain to see what a yellow color will look like in an absorption spectroscopy. Does it absorb yellow color, or is it transmitting yellow? We're going to find that out during the lab. So hopefully you got a little better experience understanding how we might do column chromatography